In the previous episodes, we have already clarified the fate of a civilization, the capability structure of a civilization, that is, the core driver, the geographic structure on which a civilization relies, that is, the structural landscape. Together, these two determine the basic direction of a civilization. However, a civilization's fate is not a completely static structure. Between the core driver and the structural landscape, there is a long-term process of interaction, mutual adaptation, and mutual change. The structural landscape influences what kinds of cognition, technology, and organization a civilization develops, and a civilization's cognition, technology, and organization, in turn, continuously reshape how the landscape is used, integrated, and bounded. In other words, a civilization's fate is not fixed in place, but constantly evolves through ongoing internal adjustment and feedback. Only by understanding civilizational fate as a dynamic structure, we can clearly see why civilizations exhibit different historical tendencies, such as expansion, contraction, integration, and fragmentation. While internal structures are continuously changing, civilizations also encounter various forces from outside: war, trade, technological diffusion, climate change, the rise and decline of roots. These external forces are not part of a civilization's internal structure, but they can exert driving, disruptive, or even destructive impacts on that structure. These external variables are what we call a civilization's contingency. A civilization's fate defines direction. A civilization's contingency changes rhythm. To understand the dynamics of civilization, we must see how these two sets of forces operate together. Let us first look at how the three core drivers of civilization and the structural landscape adapt to and shape each other. First, the core drivers of a civilization adapt to the structural landscape over the long term. Why did China develop the unified worldview of all under heaven belongs to one? As discussed earlier, its core agricultural region is a continuous plain belt, stretching from the Guangdong Plain to the North China Plain and further to the middle and lower Yangtze River Plain. There are no major mountain ranges cutting across it, allowing the region to be integrated at low cost. In terms of rivers, the Wei River, the Yellow River, the Huai River, the Yangtze River, together with their tributaries, form an interconnected water system. During the spring and autumn and warring states periods, sections of these rivers were already navigable. Combined with the canal projects of the Qin and Han dynasties, this system allowed grain, manpower, and armies to circulate within the plain belt. Such a structural landscape meant that the cost of internal unification in China was lower than the cost of fragmentation. As a result, a unified worldview of all under heaven emerged at the cognitive level. At the organizational level, a centrally unified county system and bureaucratic structure developed. And at the technological level, water control and intensive agriculture advanced. These core driver structures were, in essence, long-term adaptations to a highly connected structural landscape. Why then was Europe unable to achieve long-term unification, instead giving rise to city-states, feudal principalities, and later nation-states? Because Europe's physical geography is naturally fragmented. The Alps split north and south. The Pyrenees isolate the Iberian Peninsula into its own world. The Apennines kept Italy in a long-term multi-city-state pattern. The Carpathians block the East European plain. The Balkan Peninsula is divided into multiple independent regions by mountains and river valleys. In addition, Europe has a highly fragmented coastline. Along the Mediterranean, Adriatic, and Aegean seas, harbors, peninsulas, and islands are everywhere. This structural landscape makes it difficult for any political power to integrate Europe at low cost. As a result, a tradition of multiple sovereignty emerged at the cognitive level. At the organizational level, confederations, parliaments, and city-state systems developed. And at the technological level, continuous innovation occurred under intense competitive pressure. This, too, was a long-term adaptation to a highly fragmented structural landscape. But the structural landscape of a civilization can also be reshaped in reverse by its core drivers. The structural landscape is not fixed. When a civilization's technological, organizational, and cognitive capacities become sufficiently strong, it will actively transform land, water systems, and routes, turning an originally natural landscape into a human-engineered landscape. Ancient Chinese water control projects are a classic example of technological revolution, reshaping China's geographic landscape. From the Warring States period to the Qin and Han dynasties, China carried out a series of projects capable of rewriting geography. These were not local projects, but foundational infrastructures that directly altered regional connectivity and agricultural structure. First, the Dujiangyan irrigation system, initially completed in 256 BCE. It turned the Chengdu Plain into a super grain base that never silted up. The effects of Dujiangyan were extremely clear. It diverted the Min River, solving problems of flooding and sedimentation. It stabilized water supply, turning more than 5,000 square kilometers of the Chengdu Plain into a high-yield irrigated zone. It fundamentally increased agricultural output. Across the Sichuan Basin, Dujiangyan transformed an uncontrollable river into a controllable agricultural machine. This made Sichuan one of the Qin state's most critical granaries, greatly strengthening national power. Second, the Lingqi Canal, opened to navigation in 214 BCE. It artificially connected the Yangtze River system with the Pearl River system. Its functions were linking the Xiang River of the Yangtze system with the Li River of the Pearl River system, creating humanity's earliest north-south inland water transport corridor, allowing Qin armies to move south by water from Hunan into Lingnan. The Lingqi Canal, for the first time, connected two water systems that had never been linked, bringing South China into the Qin political sphere. Third, the Grand Canal, which largely took shape around 610 CE, during the reign of Emperor Yang of the Sui dynasty. Its functions were connecting four major river systems: the Han River, Yellow River, Huai River, and Yangtze River, integrating North China, Shandong, Jianghuai, and Jiangnan into a single agricultural economic whole, allowing southern grain to be reliably transported to northern political centers, bringing China into a unified economic structure of southern grain feeding the north. The completion of the Grand Canal completely stitched together the northern and southern agricultural belts into a national-scale market. Fourth, the Yellow River Management System, which turned the most unstable river into a manageable risk through levee construction, flood diversion, and dredging, by reducing the frequency of major course changes through an integrated engineering system, allowing farmland along the Yellow River to remain cultivable over the long term. Although the Yellow River remained volatile, these control projects significantly enhanced the state's ability to manage ecological risk. Now let us look at an example of how an organizational revolution reshaped the landscape. How Rome artificially stitched together Europe. The Roman Empire was able to span 3 continents, not because Europe itself was easy to unify, but because Rome's organizational capacity was strong enough to forcibly connect a geographically fragmented landscape. Rome relied on 2 organizational revolutions. First, the legion system, a standardized and replicable system of governance and military organization. Each legion consisted of roughly 5,000–6,000 soldiers. Its organization, training, and logistics were all highly standardized. It could be replicated and deployed anywhere across the empire. This allowed Rome to maintain consistent administrative and military efficiency across distances of thousands of kilometers. The legion system laid the foundation for modularized, unified governance. Second, the road system, the infrastructure that transformed European connectivity. Rome built the world's earliest continental road network, with a total length exceeding 80,000 kilometers. Core routes included the Via Appia, the Via Egnatia, and other major roads. They connected the Iberian Peninsula, the Italian Peninsula, the Balkans, Anatolia, and North Africa. Armies, taxation, grain, and trade could all circulate within a single system. This system forcibly transformed a Europe fragmented by mountains, isthmuses, bays, and plains into a manageable spatial network. Through organizational revolution, Rome fundamentally altered Europe's structural fate landscape. On the map, you can see Europe's physical geography remained fragmented, but Roman roads connected what was previously unconnectable, forming a fully integrated network. Geography no longer determined connectivity. Institutions determined connectivity. This is why Rome was able to form a unified empire across Europe, Asia, and Africa. Not because geography allowed it, but because organizational capacity was sufficient to rewrite geographic constraints. Finally, let us look at an example of how a cognitive revolution reshaped the landscape, how Islam redefined civilizational boundaries. The regions of Arabia, North Africa, and Central Asia are among the most geographically fragmented in the world. Deserts, mountain ranges, scattered nomadic and oasis settlements, high transportation costs, and highly fragmented tribal politics. Under traditional tribal cognition, these regions could not be integrated into a single civilizational system. The reason Islamic civilization was able to expand from Arabia to Spain and the Indus River within just 100 years was a new landscape created by cognitive revolution. Ummah is a concept of a community that transcends geography and ethnicity. The core meanings of Ummah are: faith is more important than tribe. All Muslims belong to a single community. Politics, law, and social norms are unified through religion. This meant that civilizational boundaries were no longer determined by geography, but by networks of belief. Ummah brought previously disconnected regions, the oasis city-states of the Arabian Peninsula, the agricultural zones of North Africa, the Iranian Plateau, and the Central Asian steppe, into a single political religious system. At the cognitive level, this form of boundary construction beyond geography greatly reduced the cost of expansion and increased the speed of administrative integration. The result was extremely rapid expansion of Islamic civilization. A territorial reach of roughly 13 million square kilometers, geographically fragmented regions became cognitively unified, from geographic fragments to a civilizational block. This is the most typical example of a cognitive revolution, reshaping the structural landscape in reverse. A civilization's core drivers are shaped by the structural landscape and in turn reshape the structural landscape. This is the deepest logic of a civilization's dynamic fate structure. A civilization's contingency refers to those forces that come from outside, yet are capable of changing the course of civilization. These forces usually come from several sources: war, trade, technology, the natural environment, epidemics, and changes in transportation routes. They may seem intangible, but in reality, each of them leaves clear traces on the map. War and invasion refer to military pressure coming from beyond a civilization's borders, which can directly alter territorial boundaries. And political centers, the Mongol westward campaigns of the 13th century, are a classic example. From the Ordo steppe, they advanced westward along the steppe belt into Russia, Poland, and Hungary. In just over a decade, the political structures of Eastern Europe were completely shattered. A massive pressure line, running from East Asia straight into Central Europe, forced the center of Eastern European civilization to shift toward the safer West. This is how contingency, through military routes, reshapes a civilization's fate structure. Another form of contingency comes from changes in trade routes and external corridors. When global or regional transportation arteries shift, old centers decline, and new centers rise rapidly. After Portuguese sailors rounded the Cape of Good Hope in 1488, the trade advantages accumulated along the Mediterranean for thousands of years were replaced within decades by maritime routes. Atlantic Europe, once a peripheral region, became the core of the new global trade system. Technological diffusion is also a major form of contingency. When a breakthrough technology spreads across regions, it alters the relative balance of power between civilizations. Gunpowder is a classic example. It spread from China to Central Asia, then to the Middle East, and finally into Europe. Once in Europe, gunpowder was transformed into matchlock firearms, cannons, and entirely new systems of fortification. This directly propelled the military revolutions after the 16th century. Natural disasters and epidemics are sudden forms of contingency. They can rapidly reset population levels, labor supply, and fiscal structures. In the 14th century, the Black Death spread across Europe, along ports, trade routes, and river valleys. Europe's population at the time fell by roughly one-third. The sharp reduction in labor increased the bargaining power of peasants, undermined the feudal system, and forced a restructuring of the economic order, eventually giving rise to capitalism. Climate fluctuations are slower and deeper forms of contingency. By altering precipitation patterns, temperature zones, and agricultural production areas, they transform the economic foundations of civilizations. During the 17th century, late Ming Little Ice Age, the main wheat-producing regions of North China suffered consecutive crop failures. Famine and fiscal crisis reinforced each other, directly accelerating the collapse of the Ming dynasty. This was not the result of a single battle, but of an entire climatic zone shifting southward. Another form of contingency comes from the rise and decline of sea and land corridors. When a new transportation corridor opens, economic and strategic relationships between regions are rewritten. After the opening of the Suez Canal in 1869, the voyage from the Indian Ocean to Europe was shortened by nearly half. The Mediterranean once again became a global trade choke point. All of these seemingly intangible external forces, invasion routes, trade sea lanes, paths of technological diffusion, shifting climate zones, and changes in sea and land corridors, continually impact the internal structures of civilizations like the tides. Now, we have finally completed the civilizational fate model. What we call a civilization's fate structure is not a static framework, but a dynamic process, continuously shaped by both internal and external forces. The three revolutions of the core driver and the structural landscape in which a civilization is embedded adapt to and reshape each other, together forming an internal structure that is constantly evolving. At the same time, external variables, that is, contingency, continuously exert pressure on the structure. Fate defines the structure and direction of civilization. Contingency changes the rhythm of its movement. Fate is the skeleton. Contingency is the tide. This is the complete logic of the civilizational fate model, a dynamic structure driven jointly by internal interaction and external variables. This is Fate Map. View the world through fate. Decode civilizations with maps. In the next episode, we will bring heroes back into civilization and examine whether they truly have the power to determine its direction.